which is a spin-off from the Fraunhofer Institute located in Darmstadt, Germany, and we have over 15 years of experience and know-how in tracking technologies for augmented reality applications. Our core system, called VisionLib, is a tracking solution, mostly targeting industrial augmented reality use cases. And it is a deep tech, horizontally placed software component. The idea is to use polygonal 3D mesh models as a tracking reference to detect and to track the physical counterparts of these models in camera images. The functionality can be used not only for estimating the position and orientation of an object, but also for advanced vision tasks like the detection of state changes of an object. With this object tracking, many essential industrial augmented reality use cases like manufacturing, maintenance, training, or quality inspection can be addressed. The VisionLib SDK is a cross-platform, cross-device SDK which can be deployed on common mobile platforms like Android or iOS, smartphones or tablets, but also on standalone Windows systems or the Microsoft HoloLens. Most people these days use the Unity 3D plugin we provide, but we also have like native interfaces, like a native C interface, an Objective-C interface, and also like a JavaScript interface, which can be used to integrate our VisionLib tracking engine to any application layer. So what makes the tracking for industrial augmented reality applications so difficult? Regarding the tracking technology, the challenges are to provide a precise and reliable localization so that the augmented reality content sticks at the correct position in the real world. Since, like, if instructions or annotations would be misplaced in the AR application, the whole application would be completely useless. In industrial scenarios, the lighting conditions are often challenging. Objects can be dirty or partly occluded, and the tracking should still be robust and resilient. Very important is the ability to apply the tracking at any object of the same type in any surrounding. So, for example, if you have a car, an AR application should work in an outdoor sunny environment in the same way as it would be like placed in a darker garage or any other place. Another challenge for getting beyond proof of concept projects or pilot projects is an easy preparation step and an automated workflow to enable and to set up the tracking. So with the object tracking approach in the VisionLib SDK, we can create a way which is very simple to use, because all you need to enable the tracking is the 3D model, which is typically available from the design or construction process of a product. There's no complex preparation step like placing markers in the scenario or pre-recording a feature map of an object. On the tracking side, the benefits are the independence from lighting conditions, and it works in almost any environment, because the tracking is independent from colors or appearance, because it's only based on the geometry. A key advantage is also the easy scalability, where when there's a very short link between the tracking reference data or 3D content and the PLM system holding the 3D data of a specific part of an object. With such a tight integration, there are almost no manual efforts to do for visualizing any 3D data correctly aligned on a physical object. Now I would like to show you some typical industrial augmented reality use cases. Here we have an application which is like a typical maintenance and repair scenario, where instructions of how to disassemble the windshield wipers are given to the user. Then here we have created a marketing and sales application which can be used to demonstrate visitors at an expo different functionalities of a product, like here the interior or the underlying technology of an electric car. Such applications can be used also as mobile sales tools or as a customer experience marketing application. Training is also an interesting use case. This augmented reality application we did is a short instruction manual which demonstrates the use of this water spectrometer and the maintenance of this device. One of the most interesting use cases, I guess, is augmented reality enhanced quality inspection based on 3D CAD data. For example, in the area of prototyping, where digital and physical models have to be compared and inconsistencies between physical and virtual models shall be detected. Also, for quality inspection tasks such as augmented reality-based verification, a model target-driven augmented reality application can be very beneficial to speed up the inspection process, for example, of incoming goods. Also, for the verification of assembly tasks, check if all parts have been assembled correctly. So what makes model-based tracking so interesting for industrial use cases? Here on the left we see the IKEA Place app, which is driven by Apple's ARKit. ARKit is one of the most sophisticated monocular visual inertial SLAM solutions, which can be used to place any arbitrary 3D content in any scenario. So for these furniture apps like the IKEA Place app, this is like a perfect solution. But what is missing is the ability to place the 3D data correctly in a physical context. So by using a geometric 3D model as a reference, the 3D content can be placed precisely on a physical model, like here the annotations on the screws of the steering wheel. And it is also possible to move the object and the content always stays in the correct place. An example here is tracking results in challenging environments with lots of motion blur and altering lighting conditions. We can see that the tracking is still quite robust, although only computer vision methods and no inertial sensor data is used here. The VisionLib SDK can also be used on HoloLens or HoloLens 2, but of course here we take advantage of the HoloLens internal tracking and also the internal sensors of the HoloLens as a primary self-localization source, and the VisionLib tracking is used to estimate the transformation between the coordinate system of the object and the internal HoloLens tracking coordinate system. A benefit is that the object can also be moved and the 2D content stays correctly aligned. We lately also published a feature where multiple objects can be tracked completely independently from each other. So this is like an example of these paperfold cars objects which are part of the Unity tutorials we provide with the VisionLib SDK package. With these multi-model features, many interesting use cases can be implemented. For example, here, the detection of different states, like a check if the car of the door is open or if the door is closed. Or here, the measurements of the distance between two separately tracked objects, like shown in this video, or the measurement of an angle of the steering wheel in relation to some other reference geometry. So if anybody is interested in trying out the VisionLib SDK, you're very welcome to register and download the SDK package at visionlib.com. There are many examples and tutorials for Unity, so it should be fairly easy to get started for anybody who's interested and try it out with any 3D model. And now I would like to hand over to Guillaume Donval from Simulia Innovation Labs at Dassault Systèmes.
Thank you, Harald, for your presentation, and hello everyone. It's great to be here, great to be part of this event with VisionLib. Let's start with this quote, which you may be familiar with already. The takeaway is simply that even though we all learn in different ways, one thing is sure: the more involved and engaged we are, the more we understand. So before you can even begin to communicate a complex or abstract idea, it's a good thing to first engage an audience. So the question for us became, what if we could use the latest advanced in visualization and AR/VR to get more insights and expand user engagement with the more and more complex simulation we create and bring more value to our customers? My name is Guillaume Donval. I'm from Dassault Systèmes Simulia and a member of the Innovation Lab, where we blend technology and creativity to demonstrate the power of simulation to reveal the world we live in. What Simulia does is deliver physically realistic simulation applications in a variety of domains for all industries. It accelerates the process of evaluating the performance, reliability, and safety of materials and products before committing to physical prototypes. Simulation is what makes a product real. That's the difference between an abstraction, an idea, a concept, and an actual physical product performing in the real world. This is what enables the first physical model of an aircraft to fly already, for example. By reveal the world we live in, we mean provide insight and discovery leading to transformative and sustainable innovation. Something that's reliable, repeatable, something you can build your business around. With that, through our strong technology-driven culture, solving holistic end-to-end industry workflows. And actually, with advanced visualization, we mean it literally. So let's talk about advanced visualization and immersive virtuality now. Here are a few examples of what we've created over the years around AR, VR, and mixed reality as well. From the Z-Space holographic screen, full cave experience, cardboard application, VR headsets, augmented reality application on mobile device, and HoloLens. As I said earlier, the simulation is no longer simply about generating data. It now involves visualizing it in context and in an interactive way as well. This goal is within our graph through what we call immersive virtuality, what others call XR. By extending its scope and encompassing more and more complex and multi-scale phenomena such as structural, fluid, thermal, and electromagnetic forces, simulation creates fantastic new opportunities, but also generates greater demands from a wider audience. In other words, simulation is no longer simply about generating data. It now involves sharing and communicating results in a meaningful and efficient way to a variety of people. So breaking silos to have very different groups aligned around a common goal means free flow of information and constant interactions and collaboration. This is where realistic visualization, augmented reality can help as a bridge between all those different teams and people. It's about moving from data visualization to a representative illustrations, a lifelike one. It's about engaging people, helping them make sense of the huge barrage of information ahead of them. And by showing it in context of the real life, it provides familiar visual references that immediately helps with understanding what's at play. It's to get people to care about the data. We see three main axes that can be used to define the possibilities offered by immersive virtuality. One is see the unseeable, to understand and explain complexity. Then there's witness the yet unmade, to make key decisions during the development process and reveal the full experience, to create the full user experience right away. This is a typical product development cycle. Starting from a current state of the product design, there's a whole set of simulation to validate and potentially optimize the model. Then it's about extracting those results and performing KPI analysis. That is done by simulation engineers. But then it's about communicating, sharing those results. Okay, you have to first you have to justify the simulation, and then you have to explain the impact of a current design to the designers, to the stylist people, to the managers, and you have to drive the change. It's about that simulation is what enables innovation. This is also a driver for leading to a better product. So following this review, and this is where augmented reality, virtual reality really helps and improves this communication. Following this review, there will be changes in the geometry, in materials, in parameters, leading to another iteration, hopefully a better design. This is so. Bringing AR in this context really helps getting faster to the best product. This is the first prototype we've made using the VisionLib technology. So using one of our 3D printed model, we brought some existing simulation coming from power flow technology. So we are using, so the app lets you overlay external streamlines, static and animated over the car, over the exterior, and over the wheel in different ways. We have static meshes and 2D planar meshes showing the wake behind the vehicle. This application also shows the interior of the model. This is a cabin comfort simulation showing the air conditioning inside the model. This is kind of a thing we simulate, and it was great to see that we can look inside the model, not only outside but inside, while keeping the object tracking. So by just disabling the occlusion, we had this effect, and it really works well. That was a great surprise for us. This is another car simulation, a set of simulations. So you can see that what we typically cannot see in nature, so the airflow around the car. We're looking at different aspects of the car aerodynamics that would typically be discussed in the design studio in order to achieve the desired car fuel efficiency. It also involves aeroacoustics. We don't hear that, but there's a noise that also comes from the simulation, the cabin noise coming from the wind. We can also overlay electromagnetic results and crash results to have this kind of global interactive experience around this physical model. This is an excavator model. We're looking at the loads generated during a dig operation and the stress distribution in the bucket and the arm. It's important to visualize and understand the distribution to ensure safety and efficiency. We're also looking at the thermal soak distribution. Once again, this is when everything is turned up, so this is dependent on geometry, the way the temperature profile evolves during this process, and we need to ensure that all the parts are kept in their safety limits. Here it's a smartwatch, so a virtual smartwatch over a real arm. We are looking at specific absorption rate where the arm coming from the smartwatch. So this is the energy absorbed by the arm, and we can also look at the far field visualization of the smartwatch antenna. So we are looking at it in context, which is really interesting. So this is a prototype with the demonstrator we've built with BMW. The idea was to really illustrate the concept of the first virtual wind tunnel. So it's about overlaying all the actual simulation results we had for this model. This is a Series 3 F30 model. We had really a lot of full simulation, very detailed simulation around this model, and we found great ways to visualize that on this scale model. And so yeah, the first case is the virtual wind tunnel, and we can see that the two worlds merge together. There's the virtual and the real, and after a while, when you use the experience, you don't differentiate much the two. You get the best of both worlds here. You can see with the use of transparency, etc. You get really this nice augmented view and experience. This app was also used to validate the geometry and to check the conformity. So by overlaying the reference geometry coming from the CAD and the physical one, we can identify discrepancies and mistakes. That was also one of the requirements for this prototype. Seems simple, but just being able to do that is a great help. And we can also overlay different configurations and different geometries over existing parts. This is the same application on the actual car. So the car at scale. This was shot in the Dassault Systèmes Montreal office on a random car, the red model, but a random car. And it's great to see the same results on an actual car. And I should note that the lighting conditions were really not good, and the app, so the tracking performed really well, given the challenging condition. It was also the opportunity to test various rendering settings, playing with occlusion, etc., to see what works best with this kind of result. So to conclude that Dassault Systèmes, we believe that the future is quite bright and exciting for simulation and augmented reality, especially coupled with object tracking. And when the two technologies are brought together, the combined results has great potential for us. So thank you. So now I'll be happy to answer your questions.